practical is measurement of numerical aperture of optical fiber. So numerical aperture is basically the efficiency with which the light is collected inside the fiber, optical fiber, in order to be propagated. So it is basically collection power, nothing else. Light through an optical fiber is propagated through the total internal reflection. I mean, this is the principle under which this type of action is there. This is the picture of apparatus which will be used for the purpose of finding the numerical aperture of this fiber. This is fiber. This is a laser beam, HNE laser, helium neon laser, which falls upon the fiber and it is collected and transmitted to this one. To this screen is there. So on the screen, you can see this. The picture is there. That is basically the rings are there, fringes are there. You can say anything. You can say. So distance will be measured from here to here, from the scale. Similarly, the diameter of these rings can be measured here also, right? This is scale I have written. Scale used to measure the distance. This is the brief discussion about this apparatus. Now this is in general what we are doing in this experiment. We will be finding the distance between the fiber that will be measured from this scale, right? You can see here, this is the distance between fiber and the screen. Similarly, this is the rings will be measured from here on this screen, right? So these two things will be measured. Now this is basically on the screen, the diameter of the ring can be measured. So because these rings are sometimes not sharp fit, right? So generally, whatever the sharp portion is there, only that will be measured. Mean whatever the bright red portion, we will try to note down the diameter of that. Right? One thing we will measure from here, and second thing will be distance. That is basically this one. You can see here. This line is there. This scale is there. This tells us about the distance between this fiber and this screen. That is required. So on this screen, you can see here, this is this enlarged portion is there. This small line we are seeing, right? So from here we will try to see the distance. This is a scale, right? You can see here, small line is there, right? Small gap you can see it is there. That is basically line, nothing else. This is the video which shows how the rings diameter is changed. You can see here only white portion we will try to clear. This is the white portion at this point. So you can see further some scattered is there. Only white portion we will try to clear. Right? So as the distance is changed, you can see distance is changing. So the diameter of this rings will be changing. So both the things we will try to make. Now this is the diameter of the laser spot. Only bright portion is measured. This is diameter, right? 1.6 centimeter, and these are centimeters, right? Similar distance between the optical fiber and screen, centimeter is 12. So distance between the screen and the fiber end, you can see. So d by 2z. This is that. Now if you want to calculate theta, theta will be tan inverse d by 2z. Similarly, so what is numerical aperture? Theta we have already calculated. So sin theta is basically numerical aperture. So no units are written because this is ratio. So no units are here. So and an important thing, when you are doing these type of calculations, so on degree mode calculator will be there, right? So numerical aperture you can see here three numerical apertures are there, we can take the average. Three numerical apertures are corresponding to three distances. Accordingly, we have a different rings also, different diameters of the rings also. So that ratio we will take, right? So you can see here, these rings are basically diameter is this one, and this distance is basically this one, right? So in this way we can find the numerical aperture of the optical fiber. So in this